Okay, you found the quick review of radical equations. So I'm going to try to quickly here go through some aspects of radical equations. Notice that our variable is in the radicand of a root. All right, so radical equation. And what we need to do is isolate the radical. That's our first goal, isolate the radical. All right, so look, there's two of them, right? There's two of them on the left and five of them on the right. So let's add a negative two of them to both sides. And hopefully that makes sense. So on the right hand side, I'm going to have plus 3 times the cube root of 2n minus 7, right? And I just moved them to the other side. And look, I also have to move this 11 to the other side. Let's add a negative 11 to both sides. All right. And so now I'm at negative 15 equals 3 times the cube root of 2n minus 7. Now I still haven't isolated the radical. So let's move that 3 by dividing both sides by 3. Okay, so here I'm at negative 5 equals the cube root of 2n minus 7. All right, now I'm ready. I've isolated the radical, right? The radical's isolated, so all by itself on one side. How do you undo a cube root? By cubing it. And whatever you do to one side, of course, you got to do the same thing to the other side. All right, negative 5 cubed is a negative 125, and that's a 2n minus 7. Move your 7, so that's a positive 7, so that's a negative 118. And then divide by the 2, and you end up with negative 59 equals n. You can go back and substitute that into the original, and sure enough, you'll see that the left side equals the right side. All right, so isolate the radical and then solve. Let me show you one other situation here. So it's a little bit more complex. And the issue here is not only do you have variables in the radicand, but you also have them outside of the radicand. And so we're going to have to seek to square both sides to get rid of this square root. The question is, do I square both sides right now? So in other words, I could do this and square both sides. But this is a binomial, and it'll be a nasty binomial because of that radical. So I could do that, but I don't want to. I'm really going to move the 4 to the other side first. So I'm going to add a negative 4 to both sides. It's going to look like that. And now my right is the radical, right? 10x squared minus 28x plus 2. And now if I'll square both sides, I still have a little bit of complexity, but it's going to be a doable problem. Okay, for time's sake, be careful. This is two binomials, right? This is a 3x minus 4 times a 3x minus 4. And so you get 9x squared, a negative 12x, and another negative 12x for a negative 24x, and a negative 4 times a negative 4 is a positive 16. And of course, here we get the 10x squared minus 28x plus 2. Okay, at this point, you should look at it and say, what do I have? And you should say, oh, I have a quadratic. How am I going to solve quadratics, right? And if you remember, 3 ways. You can either set them equal to 0 and factor, or you could try to take the square root of both sides, or you can use the quadratic equation. So I'm going to set it equal to 0. So let's go ahead and move a negative, add a negative 9x squared to both sides. That gives me an x squared. Let's add a positive 24 to both sides. That gives me a negative 4x. And let's add a negative 16, and that's going to give me a negative 14. So I have 0 equals x squared minus 4x minus 14. And it is at this point now I'm going to see if I can do anything with this as far as factoring. And I can see already this thing's not going to factor, right? So there's no way it's going to factor. You got a middle term of negative 4. So it's a quadratic equation. Okay. X equals negative b, negative 4 is 4, plus or minus the square root of b squared. Negative 4 squared is a 16. Minus 4 times a is 1 times c all over 2a. Okay, so that's doable. All right. So let's see, 4 times 14 and then add 16. Plus 16 is a 72. All right, so our radicand is 72. This is simplifiable, and so I should 2 times 36, right? Square root of 36 is a 6. Let me clean this up. So right now I'm at x equals 4 plus or minus 6 times the square root of 2 over 2, and I can further simplify by dividing my 2 into both, because remember, technically you're supposed to split it up. All right, so here, just quickly, it's supposed to be a quick review, right? We divide the 2 in there and the 2 in there. You know, if y equals 2, and that was a 6, right? So 2 plus or minus 3 times the square root of 2. And there's the answer. Now, that's a little bit complex, but you know what? All that's doable. All of that's doable. Same concepts. Squares undo square roots, cubes undo cube roots, and off you go with radical equations. When you can, isolate the radical and then go from there.